G'day boys, interpreting a distance time graph now. Question 1, the distance time graph shows class 8A's journey to the zoo. They stopped for a picnic on the way to the zoo. What time did the bus leave school? So we have a look at we have our distance going up our y-axis, we have our time going along our x-axis. All right, down here at the very first point, we notice that at 0 miles recorded at a time of 9 o'clock is where, sorry, just turning the pen on, is where the journey begins. So we have our leaving time, all right, at 9 a.m. What time did they stop for a picnic? We noticed that in the question it told us that they stopped on the way to the zoo, so we track along our journey as it's increasing. All right, we notice that obviously as the time goes on, the distance is changing, and then all of a sudden our distance stops changing. So in this horizontal line here, they are stationary. Here is our first picnic spot. So what we can do is we can track along from that point back to the x-axis, and we can track down to the y-axis. We can track down to the x-axis to find our time. So they stopped for a picnic at 10 a.m. Stopped for picnic. Okay, and I'll just indicate here that the horizontal line equals stoppage. How far had they travelled when they stopped for the picnic? So here we go out to the y-axis. We notice that we're going up in 20-mile lots, so that means each bigger box is 10, so 10, 20, 30, 40, 50 miles. How long did they stop for? So we need to look here at the duration of the horizontal portion of our graph. And you can see that it goes from 10 to 10:30, so that is a 30-minute stop. What time did they arrive at the zoo? Okay, so we look at our endpoint. We track down to the x-axis. All right, and we see they arrive at 11:30. And how far away are they from the school? So here we need to track across the, oops, sorry boys. Across to the, whoops, sorry boys. Let's get the pen back on. Back to the y-axis. All right, and again, like we did in the previous question, we can count up from the bottom of our y-axis. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So they are 90 miles. I'll just quickly rewrite that. I'm not sure what happened then. So 90 miles. Okay, a second worked example. Laura goes for a cycle from her house to the post office, which is 4 kilometres away. So you can see I've already marked some points on the graph. The starting point where she stops, and the end of the horizontal stop, which is when she's at the post office, and then I've just indicated to help us with the first question. So how long did it take Laura to cycle to the post office? So we can see here she started at 11:05. She finished at 11:20, so I've drawn the line down to the x-axis to indicate that. So that is a total time of 10 plus 5 is 15 minutes. And I'll just turn the pen on again. All right, question 2, B. We're trying to work out what Laura's speed cycling to the post office was. So speed equals distance over time. For this one, we have 4 kilometres over 15 minutes. Now, it might be easy for us to express this as 4 over a quarter, or 0.25. Okay, when we do that, that will result in 16 kilometres per hour. Okay, how long did Elora spend at the post office? So as I said to you before, we've got our stop time, we've got our next go time. If we draw a line down, we see that's 11:40, so we've got 11:20 to 11:40, which will be 20 minutes. All right. And finally, work out Laura's speed cycling back home. So we're going to try and work out C. So again, we have speed equals distance over time equals 4 over 20, or 4 kilometres over 20 minutes, to be more precise. So 4 over and 20 minutes is a third, excuse me, a third of an hour. Just lost my pen. Set it up again. Sorry, so 4 kilometres over 20 minutes is the same as 4 over 1/3. Which is equal to 12 kilometres per hour.